Hello friends. So today we'll be learning about functions. So functions are nothing but some things in mathematics which takes in some inputs and produces some outputs. So you can think of it like a box. It takes some input and it gives some output y. And this is a function. Okay? And how do these functions actually look like? Let's say suppose f of x equal to x square. So this box will take in some 2 and it will put 2 in place of x, so it becomes 2 square. Or it takes some 4 and it will become 4 square. So this is really what is a function. And so now we will learn about how to find out the derivatives of function. So what is the derivative of function? This is the change of the function with respect to the change in the variables. Let's say suppose it is like f of x, it's changed by x and x is changed. So this is what is the derivative of function, and we will just see that how this derivative looks like so that we can implement it in our code. So let's say suppose this is a graphical form of a function and we have x1, x2, and this is fx1 and this is fx2. Okay, so now what will be delta fx by delta this is delta x. So this is the final value minus the initial value, and final value of x minus the initial value of x. So how to get this? So now we have already seen that x2 is the final value of x. So right now we'll choose a middle value, like let's say suppose here is x1, here is x2, and we'll choose a mid value called x, where the distance between x2 and x is delta, and x and x1 is also delta. Okay, so after this we can write x2 equal to x plus delta and x1 equal to x minus delta. Correct? So what is x2 minus x1? It is 2 delta. It's pretty simple. So we'll put these values into this function and see what it comes out to be. So we will just calculate. So f x2 minus f x1 by x2 minus x1 equal to f x plus delta minus f x minus delta. Okay, and by 2 delta. Right now, if suppose this x1 and x2 is very close to each other, so the difference is 2 delta, right? If they're really close, then what? 2 delta is almost equal to 0. This thing can be represented by also 2 delta tends to 0, like they're really closing in towards each other. So if 2 delta is like tending to 0, then delta will also tend to 0, like the half point will also come close to each other. Correct? So we'll apply this concept in whatever we have found out, that is x plus delta minus fx minus delta by 2 delta. We'll say that, let's say delta is tending to 0, like the points are very close to each other, and this is what is called the derivative of function. Okay, so What this delta is a really small number. Delta is a small number. Like delta is really a small number. Like delta can be 0.001, or really it's really a negligible amount. So this is what is called the derivative of function, and this whole thing is denoted by d of f by dx. So I'll just write very clearly so that you can understand. So df by dx is equal to limit delta is almost 0, fx plus delta minus fx minus delta by 2 delta. So it's really simple, and in the next lecture we'll be implementing this formula in our code, and for this limit we'll just take delta very small and it will work very nicely. I'll show you the practical implementation in the code. So stay tuned and subscribe to my channel. Thank you.